Hey, what's up? I gotta load up my monitor here. I'll be done in a second. All right, we are there. All right, we are there. Thanks for the light. Hey, hey, what's up? How we doing today? Is it a good day? Good day for me. I slept like a lot, so I feel all right. This is awesome. We get some good speed out of this, but it's not too crazy. But we're gonna be hooking these coils. Let's see if I can. Yeah, these ones right here, up behind each one of these, linking them in series, and then dumping them into the main drive and seeing what happens. Like exactly what's gonna happen. Um, the main drive is this coil, which is a trifilar coil, 18 and 20 for the drive. And then these two are 20 gauge coils, 1500 turns a piece. So when I link them all in series, or when I link the 20s in series, it's all the way up right now. 25 volts in, 200 milliamps. But yeah, this wheel is a little off. But we know that, right? And so when it's running like this, you're picking up that excess residual buildup, capacitance of the coils, and we're going to be having the coils behind linked up, trying. I'm having a feeling there's going to be a draw, but this is the thing that I'm like curious about. Do we hook it up to the transistor that runs it, or do we hook it back up to the coil? It's different. It's way different doing it either way because this is hooked up behind the actual switch, but I don't know how the transistor will react to that. But I think we should get started with some of it. Don't have that hooked up yet though. We'll hook it up here. So this is the contactless part right here. You just place the coil right behind it. It's not really touching it at all. There's no wires connected. Contactless. I think it fits. It's not really wireless. I would say wireless, you got to have a little bit of range. I'm going to measure how much energy we get off of this coil. Hooking the meter up to it right now. One second. All right. Kids are having an argument about something, so I don't really want to hear what's going on. If anything bad happens, I will have to deal with that. Right. That's weird. Oh, that's right. All this is AC right now. There's no rectifiers or bridge rectifiers involved with it at the moment, so I got to remember to turn it on to AC to get a reading. It looks like it's pulsing upwards, doesn't it? But at the same time, it's slowly going down. So if you could imagine that, for every 2 steps you take up, you fall down 3. So I'm gonna turn this on. Right around 11 volts, it actually starts being on. With all that wiring, that's great. I like that. We're still at 0 milliamps though. We're not drawing 100 yet. So it's below 100. I bet that'll get going pretty quick too. So currently we're at below 1 volt. I mean 1 watt. That's what I mean. Like way below. That's cool, man. That's cool in my book. All right, so from the back of the coil back here, I'm not saying that the magnets aren't influencing this time, because I'm pretty sure that these magnets have a field that'll extend beyond this long. You know, I'm pretty sure this coil is being affected by the field, but it doesn't matter. We're definitely picking up on it. Both ways in this case. I mean, the magnets are extremely powerful. All right, now the power's all the way off. And I think the cool part is every time a magnet passes one of the drive coils, it's going to collapse as the magnet leaves. There's going to be an opening and a collapsing of the coil. So we're going to continue to get power. I don't think it's going to be the same. So it's different than like a spike power. It's not the same. I'm still like figuring out what the differences are, but they're definitely not the same. Just the induction power and then like all right. Now we're going to hook up the next coil in line. I think we're going to do a straight DC connection, or I mean AC connection first. So just connecting the coils without any rectifiers in it. I was also thinking about running this kind of parallel, like having each one of these coils behind dump back into the coil in front, and I'm going to set that up too. And well, I mean, right off the bat, I'm going to say, since there is going to be no source in the end, this is not an equation that can win. I'm not doing this to make it run forever. It's just, it's not going to happen, because when you take the source out of the equation, the math is, it's not math anymore. There's going to be a source wherever it comes from. You got to have a source, and right now the source for this is DC power supply. Now there's all, I hear different ways of powering things, but that's not on the table. Maybe it will be in the future, but it is not here today. I apologize. All right, so now we got the two hooked up. See, we're getting the effect off the back of the coil when I spin it with my hand. So the induction works, it's just not as powerful. I was playing with when we take the wheel out and we hook up the signal generator, I was playing with the signal generator and all the coils, and they were making like, I can make like songs. I was playing with them because the harmonics come out at right around a little bit lower than 100. You can hear it really well, but from like 100 up, it's really cool. I did it by tens. It was really neat. So now the power's all the way off. We lose about 10 volts by turning the power off. See, like, it wants to go up, but there's too much loss. And there's going to be no doubt going to be loss on this particular build for sure. Just the base. See all the glue on the table? Just a strand of glue could fly into that. So it's this energy right here that we're going to throw back in. No, this coil always gave me trouble. Now once we get all these together and hooked together facing the right way, so like every time you hook a new one, the power is going to go up if it's the right way. In this instance, like if you're trying to zero stuff out, then it's going to go every other. And what I mean by that is start and finish of your coil. That should be it right there. Let's see what we get out of these three. Put 15 in. .7 and 100 milliamps. Let's see how many amps we're getting off of this. I bet it's like 20 milliamps. 60, I was almost there, almost on it. 35 milliamps. Now I should probably convert it to DC now that I have everything hooked up. Can convert the complete series into DC. Or should I do one into the other? I don't know. I think I should convert it all and use this bridge rectifier to do it. That's the easiest way to hook it up to the next part. It's like, I think it'll work just fine, but gave me a little bit of a worry the other day. Let's see here. I need to get 2 clips and then we're good. Oh, maybe more. 1. Here's 2. All right, so man, I love having access to at least 3 sides of my table. It really helps out. And I think what I wanted to do wasn't that. No, that's right. Oh, I should have picked that up though. Yeah, that's what I need. All right, and you see it's already got really good flywheel capabilities. The wheel is still spinning, and none of this has been done yet. I mean, the worst that could happen is it's going to stop it. You know, it's going to slow everything down. All right, I think we got some business here. At least we've changed it to DC, and then we're going to put it right back in. Nice. Getting many DC volts. That is good. All right, I'm going to get the 2 clips that we're going to use to connect it back into the drive. Maybe 3 clips. I'm going to use, but it's a rectifier, so I don't think we need to use another rectifier. All right. But I brought 3 clips just in case. All right, so first we're going to try just plugging it into the coil, because if it breaks the transistor, I want that to be the last thing we try, not the first thing. Oh wow, something's backwards. Yeah, it's well, what I'm doing here is I'm trying to take, I got 3 drive coils here and 120. And then I got 2 pickup coils behind each one of the drive coils, and I'm trying to use what they pick up to run the drive for a given amount of time. forever is not the answer to that question. Just being realistic here. Yeah, that's not hooked up right. That's weird. All right, let's see if we can run it without that. Get some juice again. Yeah, this one isn't hooked to anything. This one is gonna be hooked to something. So that's what the clip hooked on. This is not nothing. Or minus stuff like it was before. So it looks like it's actually, well, when it's on, it's going to slow it down. But if we turn it off, let's see what happens. Oh, wow. So that's it hooked to the coil. Now we're going to hook it up to the transistor, and we're going to see the difference there. Should use a common ground, I would hope. All right, now the output is equal to the input, pretty much. It's 9.48 and 9.52. It's probably, yeah, I don't know what it is, honestly. probably where I have this meter hooked up at. Usually it's pretty strong there at the multimeter, or I mean bridge rectifier, but maybe not right now. Oh man, yeah, that's just whistling. That is not anybody's tune. You can check it out. I don't, whatever, man. Doesn't bother me. I like the whistle. But I mean, half the songs that I whistled, I don't know the name of the author. All right. More than half, actually. Yeah. So I guess when it gets down to this speed, it works. That's a temporary fix. I gotta go get a new glue stick. Alright, so we'll give it a spin and we'll see what happens. Oh wow. I'm just excited because it starts going down and then it goes up. It doesn't normally do that. See how it keeps bouncing between, the point and then the zero is over there and then the one is over there? That's big. And of course, it's not gonna like do that forever because there's loss. Every single time this thing goes around, it's gonna go around slower the next time. I mean, if you put it in a vacuum, you're increasing the quote unquote efficiency by like 60%. There's already ceramic bearings in here. That's 80%. But it's just a percentage of improvement. It's not a cure-all. But eventually we're going to be making so much power that it isn't going to matter. It's just not going to matter anymore. People are going to, look at that. It's going up. It's going way up. That's awesome. So currently it is going up. The amount of voltage that is being generated is going up. And there's no power going into this thing. Will it go down? I don't know. Or is this like where it would be if it wasn't moving at all? Those are the things that I would wonder. But I don't think so. Let's stop it. Yeah, see? Look at that. Wow. Oh, I think we made something here, guys. We made something. Yeah, let's see if it happens a second time, though. Yeah, that's going up steadily. Oh! That is awesome. It looks like it's not going to happen a second time. It might have even been a fluke. See, meter, you know, you got to do it at least 3 times to even begin to know whether you have a good reading or not. But I did hear it rattling a little bit, and it didn't rattle the last time after it stopped rattling the first time. So that little rattle there is a lot of friction. But here, it's starting to climb again. Once it sinks into that rhythm, I guess. There's a slower rhythm, but it's definitely, you know, that's real. I did that with my finger. That's awesome. All right, let's see if we turn it up power-wise. I think we've proven quite a bit right there. Now what I think is going to happen is it's going to slow down when I turn the power off all the way to that point where it's going real slow, and then the power will start to increase. Until then, it'll be a constant decrease for the most part. Just going to wait till everything starts jostling on the table again, and I'll turn it off. There we go. We'll see what happens. I mean, the power is now off. Yeah, I know, right? Spin that thing with my finger. Nice haul back. But I bet you any moment, it's going to take a little while, but any given moment, that's going to start to go up. It's going to stop going down. It's going to start to go up. And this is all off induction, but it's also off the collapse of the coil, the drive coil. When the drive coil shuts off, it collapses and then a wave through this coil. And each one of these coils pulses at the rate this one does. So each one of those pickup coils is picking up roughly the same rate. I mean, this one coil here is a tri-filer coil. Those are all single file coils. All the pickup coils are 32 gauge, running from 18, let me think here, 11,000 turns to 22,000 turns. The drive coils are 18 gauge and 20 gauge in series, about 333 turns, and then two 1,500 turn 20 gauge coils. As you can see, it's going up now. it's slowed down, it's gotten in sync, and it's starting to produce more energy than it is. The amount of energy that it is producing is going up without a power source. I don't know if that's what that means. It just is. Maybe it just is. And that's cool too. Because I know this is going to stop. I mean, the issue isn't whether or not it's going to keep going. But this looks like the better end of it. And that isn't on the rectifier though. That's not on the end of the energy. I just have the beginning of this coil and the end of that coil hooked up to the meter. So that's the reading we're getting, is how much AC is being generated on those three coils. Here we go. Now we're on the downspin. So like when it sinks in, it'll start spinning a little bit faster. And then it'll, of course, loss will catch up to it. We're not done yet, it looks like, though. Yeah, for the most part, it's a magnet motor. I'm just trying to see exactly, and it's hard to do it with this particular rotor because it's got such good flywheel capabilities. When I turn it, like a wheel of fortune, it'll produce about a volt for, 20 minutes. And that's cool, I think. I mean, it is currently being run back into the transistor, and the collector is collecting the energy from the three pickup coils right now. I'm glad that nothing bad has happened to my transistor. But when you turn the source power on, you can see the voltage climb, and that's the transformer aspect of it. That's why the coils are so close, because it's going to produce that EMF that is so good for it. And this currently is 25 volts in, 200 milliamps. So that's 5 watts. We'll do 15. 15 is probably too much too. Let's do 12. But now we're at 0. Yeah, I mean, it's actually a lot of work. It's fun though for me, but yeah, I'd say it's baseline getting stuff that you didn't put in out of it based on interactions with the components have with each other. Either magnet to copper, magnet to magnet, capacitor, transistor, how different parts of the transistor are hooked up to other parts of your stuff. Yeah, you could tap in anywhere, pretty sure, but it's all in some equation that we haven't found yet. It's all legit. All of it is legit. There's no part where you're breaking rules, is what I'm saying. You're going to figure it out eventually. We just don't know what the rules are yet. A lot of people thought they did 300 years ago, but it's like not spot on. exactly what they are. It's like you might have to do what, I don't know. My brother said, this is what we're gonna do. We're gonna remake the meaning of some words. We have to, because free energy rubs a lot of people the wrong way, but we all know it's there. It's just not really free, but whatever. I believe that there's energy there that we can get that we don't get, but that doesn't mean that we're not going to get it. You know what I'm saying? It's like, I think it's all good. I think everybody and all the different moves that people are making is really, really good. I just don't think that it's like, it could be groundbreaking in like technology wise, but it's like it should be looked at as like, oh, maybe I misunderstood this, or oh, um, maybe this was incomplete, because it's just, it's due diligence, man. It's showing respect to those that came before you, and it's like important. You don't have to waste time doing it, but I mean, it's like, yeah, the laws of physics are there because some, um, you know, brainy people decided to put a lot of time and effort into proving that these laws were actually laws. But I still think, even with all of that data gathered and experiments done and all that stuff, it's still incomplete. There's so much more there that we just don't know about yet, and we're figuring it out as we go. A lot of reverse engineering going on, a lot of and the place down in Florida, like the Secret Garden, it's made out of rocks, really heavy stones that are single rock. They're not, you couldn't like put them together or anything. This guy moved them with his bare hands, and I believe that this guy could resonate with the stuff around him. He was the Tesla coil. He was the thing that actually lifted the freaking stone off the ground. It wasn't, he didn't have a tool in his hand or anything. A lot of people want to say he had a tool in his hand. He was holding a Tesla coil. I think he was the Tesla coil. Absolutely, man. I think there's a lot about humanity and where we came from and all this stuff that we just totally forgot. No, this is actually a proof of concept, Mr. Jackson. And although you couldn't tag this one, I'm sure if we scaled it and made it into a toy, that we could do that and get our hands on some better bearings and some reduce the friction a ton and all this stuff, make it out of really light plastic, and it wouldn't be so, maybe lighter magnets and all that stuff, make it super duper light and it'll go super duper fast when some kid spins it with his finger, and that'll be awesome. Oh man. See, I'm yeah, Yeah, I don't know. Oh wow, there it is. See, and then my meter will do stuff like that. We got a square wave now. That's 6 volts in. Spikes are very shallow. I'm wondering if there's anything that I can do to separate. I think there is. The power going in from either source, I gotta put in another diode. I think this is what I gotta do. Because they're commingled right now. Whenever I turn it on, it's the same reading in and out. I think it's because of this. It's only about 30 volt peak to peak. That's not good. So that says 3 volts. So let's put 3 volts in. Oh, okay. I see. It's still linked together. Mm-hmm. So it says we're getting like 10 volts out. which is more like 4. I'm only putting 3.8 in. I don't know if it's even going to remain on. I mean, there's so much wire in the drive that 3.8 might not be enough to run it. Here we go. But we're now, it doesn't matter because we're making less. I don't know. I think it's really cool. I've never gotten a meter to actually go up for a consistent amount of time. I got it to go up like once or twice, but not over and over again. I wonder what else we could do. Could take the wheel off, put the signal generator back on. I could make different bobbins. I mean, the fact that they're made out of iron infused PLA is now in hindsight not such a great idea. Considering it's all, well, that might be an issue actually. Let me put those back in. Keep the coils away. It's just that these magnets are like so powerful that putting a core in, these cores, man, it's quite a pull. Those magnetic, the fluxes should be fluxing now. But it's already iron infused PLA, so I don't know. There was a small amount of iron in the core already. Yeah, that's awesome. And now the only one without a core is the blue one. Way better with a core in. Way better. But now you can see that as it slows down, the core starts to grab it. Let's back it up just a little bit more. What I'm saying, for the most part, the energy that they pick up out there will be the same. It just won't have the same influence on the wheel. Which is okay, because it can't go that fast anyway. So I think that's good. Power's off. There isn't a maglev on this right now because I didn't want to elevate all my coils. So it's firmly on the ground too, like just held up in the center. I think that's awesome. I think that's really, really cool. I think two things are cool right here. Both this one and this one are still generating for the two pickup coils because it's all hooked up to the trigger coil in this coil. So all this is wrapped in and then it's linked in series on a 20 gauge strand in here. Now what I can also do is detach the 18 gauge or the 1 millimeter from the 20 gauge, and have the 20 gauge be in series, and have the 1 millimeter just be on this coil right here. It's another thing I can do, but this allows me to put a lot more voltage in with a lot less amp cost. And it's also proving that the propagator that I'm working on, that this is basically that put together in a different way, that it'll work as well. You know, it's important to try out different ways of. I just have to I gotta find the right configuration for the pickup coils. Now I'm planning on having like 4 of them per section. So instead of one big one like this, have 4 smaller ones, each with their own core, and each between 3,000 and 4,500 turns themselves. So got a lot of work ahead of me for that. But I think that'll work, and it'll be versatile. It'll be able to be changed. Like if I want to do parallel setup, I can do that. If I want to do a parallel series setup, I could do that. If I want to do a series setup, I could do that, because I'm going to have 4 coils of equal length. Something like that. And I have room for a core in the middle. They're going to be double this size though. These are too small. They don't get enough done. And they're all 32 gauge. So, oh no, one's 38 gauge. The clips won't even clip a 38 gauge. So I'm not even interested in anything below 32 right now. Or above 32. It's so confusing sometimes. Wow. So that's working like a transformer more than it was before. But it definitely is more or less a transformer. All right. Another thing that I wanted to try, just with this configuration, is putting the pickup coils next to the wheel. Moving everything in just a little bit and putting these pickup coils up here. Now there's going to be a lot more drag on the wheel, so I don't know. Should get a lot more than what I'm getting though. I feel like some of it's hooked up backwards. We shouldn't be getting the same that we're getting off of the back of the coils. It shouldn't be the same. Looks the same. So I think I might end up doing them in parallel. I could even try and hook that up right now. More light? I can't get more light than that. I can move this to try and block the light if you want. All right. So we're not going to do them in series. We're going to do them, one for one. So these two will go together, these two will go together, and these two will go together. But they are going to be hooked in, I don't know, will that work? I think I got to hook these together in with the rectifier then, which we can do. I'll give it a quick test spin, make sure it's working before we move on. So I want to do a little poll. I want to see who thinks more energy is going to come off the back of the coil, or who thinks more energy is going to come off of the wheel. All right. And I think by separating each section by a diode, I will allow these coils to be parallel, not get all jumbled up. That's what it was. Oh, man. Stupid. Uh-oh. Here we go. It was one wrong clip that was making the meter all weird. I figured out which one it was just now. This is 25 volts in, about 100 milliamps. 2.5 volts. I don't have anything hooked up. I was just making sure that it was working. With a rectifier in between them. All right. Now, we got a little coil here. And, all right. That one. Kind of hard to know what to do right here. I'm not an electrician, and there's like options. So I'm like, okay, what do I do now? I'll worry about that later. I don't even see a place to hook it up right now. All right, let me get the next one. Oh, I see. I see now. It's a little, I don't know if I have enough clips to do that though. What the hell? All right, there we go. Shit. There it goes. Oh man. Now my brother's voice is ringing in my head right now. So you needed to put that stuff in your other hand down and handle that coil with care. Oh man, that is a tragedy. I think with the proper coil dimensions and the cores involved, we'll have enough power to propagate. Without having it be perfect. You know, it'll just propagate on its own because there's enough power there. There it is. So what I'm going to do is I'm going to hook all the coils directly to the transistor individually through one diode at the end. Alright, so those two are hooked up. I don't even know if I'm going to do the third one because I just broke the coil. Alright. Yeah, we are. And I'm glad this is it because we're running out of clips. The last long clip, and then I got the broken little ones. Nice. And then this clip will go to the ground, but I never know where that is. I'm thinking it's going to be this is being really iffy in my mind. No, I'm not going to do that. We're going to clip it. This is why the bridge rectifier is easier to use. I got the two grounds for the pickup coils, and they need to go. I want to put them on a transistor. No. Man. Okay. Go. Oh yeah. Do we? Okay. I think it's great. And I remember I didn't have really a place to hook this up at. I'm gonna hook this side up on the blue coil, and the other side up on the other coil. Don't have a name for it yet. Little monster comes to mind though. All right, man, this it's gonna be worth being this exhausted if I get it right. But I feel like the journey's not over yet. All right, let's see here. Oh, I see why we're not getting any readings, because they're parallel coils. Man, I'm going faster than I can keep up with myself. That's amazing. So I'll just hook this up to the little one. Haha, that tinfoil is flapping in the wind. So what we have here is we've got this setup and that setup in parallel with each other, but both pickup coils are dumping parallelly into this transistor through a diode that I have both ends connected to. But it's the same deal. It goes for like an hour and then it'll stop. Yeah, it's all good though. I'm gonna keep building weird stuff that's gonna eventually, but I don't have a goal to make a machine that's gonna run forever. That's not a goal of mine. What is a goal, however, is to make it work. I'm going to use the capacitance of the coils to as part of what's going to make this work. Some kid's going to be able to spin this with his finger and he's going to be like, oh man, it didn't stop yet. It's not just going to be a balanced fidget spinner. I might use a bearing of a fidget spinner, but I'm not going to use a fidget spinner. Those bearings are good though. Bearings are awesome. I might use one of those. But yeah, technically it would be a fidget spinner, but like a special one. Yeah, I wish I could move those coils in closer, but they're magnetic, so I can't really do that. I mean, like, oh man, I wish there was just like some way that I didn't need to like make a bunch of sawdust to fix this thing. I'm talking about the base here. Just make it look neat, fix it, have all the holes like that I've made still work and all that stuff. And I don't think anybody's going to be able to give me an answer to that one. That one, that's a toughie. Definitely going to be some sawdust. So, what I want to do is I want to take my propagator coils and I want to pulse them with the signal generator around this wheel, and I want the wheel to move. So I want to use my propagator to spin my pulse motor rotor just because it popped into my head. without using the trigger coil though. We're not going to use the trigger coil. We're not going to use a 555 timer, which would be nice. We're not going to do that. We're gonna finger feel the frequency on my signal generator of how fast this thing can go without breaking. Ugh. I think that's gonna be sweet. See, then I back off the iron a little bit. It's good. It's good. It's just those two coils are part of the drive, so they don't need to be in. They don't need to be influencing the wheel at all. But they are hooked together with the drive. So when I turn it all the way up, it's only drawing like 100 milliamps at the most. And when this energy gets recycled back into the drive, it's got to go through, 4,000 turns of 18 gauge and 20 gauge. And there's no amps, so I'm thinking that that's going to eat half the voltage right away just to simulate the amps that's needed. And it's really only about 100 milliamps or less. I love that, man. It's still going. And the output is still basically increasing. It's not going to be anything significant or major. It's just was down at 1 volt. Now it's up by 2 volts. And you beg to wonder if it's just the momentum, the fact that it's big, and all that. Even with all that being said, the voltage would not be going up. It just wouldn't be going up unless there was power involved. Anyway, I think this is great. Even though it's minute, it's on a very small scale, I think it's great. This isn't just like, this is more than putting in. This is actually running the motor. And kinetic motion is always going to take a little bit more energy than non-kinetic. And I'm probably more current. It's not going to, and this is going to, when it stops, man, it's all going to stop. But I'm going to leave it running this time. Yeah. Looks like it's coming to a stop though. When I was running this drive in parallel, with the 20 and an 18 gauge, with each have their own transistor, at 2.3 volts, this thing was going like 1,000 RPMs. But this is way more wire than that. All right, we're tapering down. It's coming to a close. See, it gets into that groove and then it'll run for 15 minutes like that. 10 minutes, 15 minutes like that. It'll be increasing in speed slightly during the cycle, and then it'll, I guess, lose. But you see the meter going up. Not anymore. It's constantly going down now. Occasionally you'll see it spike up a little bit, but once it gets below a certain amount, and I believe that amount will increase once I get a third coil. Sweet, man. That's great. That's proof right there. If it happens at all, it can happen. You can make it happen. Okay? If it happens at all, you can make it happen. It's hard to gauge how close that coil needs to actually be. But it always works. I just need to move it in a little bit sometimes. And this is just this coil we're measuring right here. Yeah, not that much. Let me turn the power off. So we're going to break it down with about 4 coils like this. They're going to be about this size, and they're going to have room for a core in the center. But they're going to be about twice as much wire as these ones are. These are all 1500. I have a 38 gauge that's like 4,000, but like all my clips, they don't clip a 38 gauge strand, and they won't, and I've tried it, and it's just, I'm not doing it. 32, that's as high as I'm going. Gotta be, maybe a 34, but 36, 38, 40, 42. I have 42, and there's no way I'm making a coil out of 42. Yeah, if you need a machine to build it, I'm not making a 42 gauge coil. It's that simple. Like one that where the tension is, held in the proper perspective. I don't have one of those. And I don't know the engineering behind it, so I can't jury rig one from my house. It's like I can't. You can 3D print a former, and then you can make coils that way. I know that. Like rotors are the same way. So yeah, I think with another coil, I would have been able to go twice or three times, maybe no, just like twice as long with the power off. But I think it's awesome. It's like fluxing like a whole volt right now. That's a lot of energy. But like the faster the wheel goes, the more energy you're gonna get. So it's still going pretty fast. So it's not a huge deal, but well, that still got some pretty good speed on it. But it's tapering down. Wow, I wish there was a way to like record except for time. Like time is easy. What's actually going on here? He's got a motor under the table. You bet I do. Wonder what would happen if I hooked up my other power supply. Because it's a 60-volt power supply. You know what? I'm not even gonna waste time wondering. I'm gonna do that. All right, let's see. Wow, that works so good. I had to cut it off even like really fast. Huh. Wow, that freaked me out a little bit. Power's off. Wow. I really would like, I'm going to make, you know, a third coil for this, but it's going to be 4 of these that are a little bigger. And then I'm going to have cores for all of it. Oh, it's going to be great. I just had a brilliant idea. Okay, we take the 20 gauge strand out of this coil, we hook it with the other two, and we run that primary drive, right? Then we take the energy from the pickup, we run it through the 18 gauge strand in this one by itself. I think that'll work a lot better because it, and then we're keeping things separate and we're keeping them together at the same time. And that way we will know more if it's working when the power's off. We'll know more about that because the drive will be isolated for the drive that's being powered by the pickup coils. It will be isolated from the primary drive. Then be able to, you know, tell whether or not it's working or not more so. But we're going to be using the same trigger strand. And the cool part about it, it's not going to take much to rearrange this. All right, let's see if we're good to move forward. The 18 gauge strand is now disconnected. Sweet. All right. So now, and just for the hell of it, I'm going to hook this coil up on the third one. Oh man, this isn't going to work. Not with these clips. All right. So now, for the 18 gauge strand, we get another transistor. And just get that coil back where it needs to be. See, that's the problem with iron infused PLA. This really needs to be like on this side of this. All right, so now we got the power going into here. We'll have power going out there, out the emitter. All right, and then the base is the trigger coil. Then we just need a light. We got a light. All right, light. Oh yeah. Just need to ground it now. Oh, we got the grounder. Sweet. Nice. Haha. All right. So we can't ground it there. Hmm. Yeah, I don't know if this is gonna, I just gotta figure out where I'm gonna put this. Maybe it'll go here. No. What does that even mean? I don't even know what you, everybody keeps saying that, or some people say that. I don't know what that means, dude. There is no explosives in this place whatsoever. There's not even enough voltage to make a wire pop. So I don't even know what you're talking about. But I hear that a lot. I mean, there's no accelerant, there's not high voltage. I don't know what you're trying to say. That it looks like a homemade bomb. I get that. Actually, I don't get it, but I hear it a lot. That's what I'm trying to say. Guy was on the wrong channel. I had to do something about that. So it doesn't look like there's enough energy really to run the second one. I mean, I think it's running, but I'm not entirely sure about that. Oh. Oh. This will make it work. Oh. We got this. At least I hope we got this. Yes. Where do I ground this stuff? Man, this is a puzzle. That might work. Is that it? Did I get it? I mean, I heard it change up a little bit. Gotta see. Oh, I see what I did. Let's see if this thing was spinning perfectly, like there wasn't any friction whatsoever. I don't know about now. Had it going on. It's not that one. Where's the other one? There's that one. There it is. There it is. So what I'm trying to do now is I separated the trifilar drive into two drives, and now I'm trying to find a place to ground the second drive. But the only problem with that is that I'm using the pickup coils to power the second transistor, and so the second drive can't be ground directly, or it won't work. I don't know if this is right though. It feels not right. And I don't think this light is ever going to light up because it just doesn't, there's no source energy going into it. I can never get a halogen bulb to light up without a circuit anytime, any place. So I'm gonna let this run for a minute. Oh no, it looks like it's pretty much just going down. As soon as I ground this other wire, it's like, it feels off. Oh, wow, that would be sweet. Here, let me try putting it right here. Yeah, so it looks like it's supposed to go someplace, but it really doesn't go there because that's what happens. I might take those cores out. I don't know I'm going to use them, but not on this thing. So we might get a little less. I just had another idea, and I don't know if it's like gonna work or not. But since I have these diodes, kind of loop that one back into itself. Oh man. Oh man. It's these damn little clips, man. They're so magnetic. I don't know. I think I'm going to call it for right now. I'm going to try and put this together again, and then I'm just going to see about taking it easy for a second. So it looks like we're going to get out of this with surprisingly little damage. And there's my diode that I was going for. Resistor. Ooh, all right. You know what? I'm going to make it super simple. Before I log out here, I'm going to take out these coils. We're just going to use one coil. We're going to mess around with the dual drive. Oh, my foot. Broke my foot. It's going to be ship shape in no time. There it all goes. All right. This is going to give me perspective. And in turn, I'll be able to give you a little bit of perspective. And it's soothing to clean up. So it's like every time you move, you gotta swear to God, it's time to take a break. It's time to take a break. You're not gonna get anything done when you're swearing to God every time you move. And this is how you handle that. Clean up. Clean that up, man. If it's all clean, keep it clean. It's worth it. That's all I gotta say. I never really get it totally clean, so I have a great appreciation for people who can keep it clean. I don't have appreciation for somebody who's just mouthing off, being like, oh, you're dirty, or oh, you need to keep it clean. No, I know I need to keep it clean. You need to check yourself. It's like people look at me thinking that I need their help. Honestly, that's what they think. They think, oh my God, this guy's such a freaking slob. I'm gonna help him out. Hey, dude, man, clean up, man. You need to clean up, man. Oh, you're not fucking helping anybody. Seriously. Get a different job instead of telling people what to do. And don't think you're not, because you so freaking are telling me what to do when you're like, dude, you need to clean your house. Like, dude, I know what I need to do. Just saying. And that's hot glue. That's not dirt. That's not going anywhere, bro. I mean, honestly, I pretty much pick up every day. Every day I do what I just did. Many times a day, actually. Get that out of the way. Gonna change up the rotor. All right. Hmm. Hmm. So 4 more. Hmm. So this should be an interesting read when they have both drives pumping at the same time. with their own source. See how much energy we get off of the dual. All right, so are we good? We need the lights. And lights are okay. The little wires. So not pliable. And I worship pliability and how easily it can adapt. This stuff is not adaptable. Nope, that's all crazy. That's crazy. It's just not adaptable. Yeah, we're going to go 42 gauge and it's going to become very flexible. Yeah, you're not going to be able to clip nothing to 42 gauge. You're going to have to robotize and, you know, everything about it. No, I mean, I made a few 42 gauge coils, but like I said, they're not very usable. Get some pretty good readings off of them though, but they're not that great. All right, where, there, here. I'm gonna set this up real quick, get a few readings off of it. You're like, no, they're probably still having problems then. All right, here we go. That's 4 volts in. All right, let's get the reading. Oh, it's not plugged in. So much richer and robust sound coming from the dual drive. So much more torque. But then again, it's not the most efficient way to run things. But you know me, it ain't about efficiency. It isn't necessarily even about power. They're doing that out there at the factories and everything, and they pay people good money to come up with the latest thing. I do this to relax. I do this to start iterating hobbies into my life and better habits, like cleaning up every day. Those are good habits to have, you know. Instead of telling somebody to clean up, go clean something. Be useful. All right. Yeah. Okay, let's turn it on. That's 2 volts in. We're at 12 volts already. It's freaking awesome. But I'm going to change the rotor after I do this once. Because it's not going to shake as much and we can really get some good numbers. And this one is north-south, north-south. So it's 2 180 north and 2 180 south for the magnet spread. And then if everything works, we'll shove this one in. Yeah, that's what I'm talking about. Woo! Those numbers. 6 volts in. North south for the win. But then again, you know, it always has better numbers with just one coil for some reason. Maybe it doesn't. I don't know. But it does for right now. Nine volts in. $12 volts in. Woo! That is going pretty quick. But this one will have a better, you know, feel. It's got very less flywheel capabilities. All right, so just a heads up, I'm gonna put on my list of words that will automatically ban you from my channel. One of them is gonna be bomb. Okay? Anybody mentions a fucking bomb on my channel, they're gone. That's just my own personal, you know, checklist. That is a no-no, and I don't care. What you saw in Afghanistan, dude, I don't care. All right, love you guys. And check you later. Peace out.